After drawing the free body diagram, our next task is to define the axes x and y, resolve the forces and write equation. So what we are going to do is, third step is define xy axis and resolve forces across the direction, two directions, whatever directions we have taken, resolve the forces across these directions, and then write the equation. The final is writing equation. So I will just show how to write the equation for these above examples. Okay, so first we will see this incline example. Suppose we have taken this 4 examples. This is A, this is B, 3 examples, and this is C. So I will write for A. For A, what should be the axis? See, so taking axis is up to us. It is completely up to us that how we are taking the axis. We can take any axis, but we should take the axis in such a way that solving process is easier. So suppose in this one, object is kept here. We know that object is not going to jump on the incline or going to move down the incline. It will always be in contact with incline. So in this case, in this kind of cases, if we take x along the incline and y perpendicular to it, then the solving equation becomes comparatively easier. Okay, so if you have some system given and you know that in this particular direction object is going to move, so in whatever direction object is going to move, in that direction you should take x-axis. So you can take any axis, but if you take x-axis along the direction of motion or along the direction of probable motion, it is easier to solve equation. The other axis also, if you take other axis, then also you can solve, but the process will be little lengthier. So the better to take the x-axis along the probable direction of motion. So direction of motion of this object is down the incline. So we are taking axis like this. So take axis along, take x-axis along direction of motion. Direction of motion or probable direction of motion, whatever. And y will be perpendicular to that. Y is perpendicular to x. Okay. Now we will split the forces. We will resolve the forces. So how do we resolve? So we will resolve the forces. So this is y and this is x. So mg is what? Mg is vertically down. Mg is like this. Okay. And this angle will be theta. How this angle will be theta? Because this angle was theta. This angle was theta, and since x is parallel to incline with horizontal, it will make angle theta. And see, mg is perpendicular to horizontal direction, so this will also make angle theta. And so what we are doing is we are taking the axis. So axis should be taken, the x-axis should be taken along the direction of motion or along the probable direction of motion. So we have taken the x-axis like this along the incline, and y-axis perpendicular to that. Now we write the different forces. The mg is going to like this. Mg is since vertically down, this mg is going to make angle theta with the y-axis, and the normal is going to be exactly along y-axis because normal is perpendicular to the incline. Now we write equation along x. So if we write equation along x, we will have component of mg along the x direction. Normal will not have any component along x. So component of mg along x will be mg sine theta. This is the force. So what do we write? F equal to ma. So we will write mass of object, whatever mass it is given, suppose, and into acceleration along x direction. So in this way we can write. This is actually coming from where? Fx equal to max. So total Fx is mg sine theta only. So in this way we can write. And if you solve it, you are going to get ax equal to g sin theta. So this much acceleration will be there for the object on the incline. Similarly, if we write equation along y direction, we have only normal force and we have a component of mg. So normal is upward and mg cos theta is downward. So normal minus mg cos theta, this is the net force. And since the object is not accelerating in y direction, it will be equal to 0. Actually, this is coming from where? This is coming from Fy equal to MAy. And Ay is 0. Object is not accelerated along y direction. Along y direction, it is not moving. So the Fy will be equal to 0. So the normal will be equal to mg cos theta. So you can directly find the value of normal like this. So if you solve this equation, you are going to get two things. One is the acceleration of the object, and second, you are going to get normal force by the incline on the object. Thing like this. And that is MB and MA. This is MB, this is MA, and N1 and N1 here and N2 here. So these are the things given. Now what we can do for this question is, we can find, since this object is kept on rest, there is no acceleration. So all the forces will be balanced here. So if we write for MB, what are the different forces? So MB, weight is downward. So MBG is downward and the normal is upward. So normal minus MBG, this must be equal to 0. Here no need to take axis, because we can take the axis, we can take x and y, we can take like this. So the equation is along y, this is along y. Along x direction there is no possible motion. Along this is along y. Along x direction there is no possible motion. So we are just writing the equation along the y direction. So normal upward and MBG downward. So normal value will be MBG. No need to take the components in this case, because the object is not on an incline or not having direction in 2 dimensions. It is just kept on a surface and we need to solve it. Similarly for MA, if we write, it will be how much? It will be on MA, what are the different forces? So N2 upward, N1 downward, MAG downward. See, N2 is upward from the lower surface, N1 downward from the upper surface, and MAG is downward. So that will be equal to 0. Net force is 0. So we will write the N2 equal to N1 plus MAG, and N1 we have already calculated. From here we can write, this was B, this is A. Okay, so N1 we have already calculated, that is MBG plus MAG. So N2 will be this much. So what we conclude here is, suppose the upper one was 2 kg and lower one was suppose 5 kg. If the upper one is suppose 2 kg and the lower one is 5 kg, means the normal force at the upper surface will be equivalent to 2 kg. That will be 20 Newton. So here it will be 2 into 10, 20 Newton on the upper surface. But if you see on the lower surface, since the lower surface is having this much, MAG plus MBG. So MB is 2 into 10 and MA is 5 into 10. So we are getting 70 Newton. So the at lower surface, the normal is corresponding to both the masses. You can see the MAG and MBG both are coming. Although we have not included the MBG mass directly on the lower surface, but it is coming through the N1. The N1 is what? N1 is equal to MBG. So that's why we are getting these two terms together. And that lower surface, the normal is due to combination of both the weights.